Let's make a custom function in MATLAB. To do so, we're going to start by writing a script. We'll put it inside a script called cuber script because the example function is going to be a cube function. So we'll start by writing our script. We'll clear all our variables, clear the screen, and then we'll write our function. So the function we're going to write is a cube, so let's put a little comment in to say what we're going to do. So a cube function, we know we've got some sort of coefficient times x cubed, and then another coefficient times x squared, and then another coefficient times x, and finally a fourth coefficient. Now our code's going to look a little bit different from that, but that's what a cube function is. So let's call our cube function cuber. And let's say what cuber is going to be. We're just going to say cuber is going to be a function that has two inputs. X, the only variable, it's going to be a one variable function, and then p, which is going to be a vector with the coefficients a, b, c, and d in it. Okay, so let's write the actual function. So we've got a, and we'll have that be the first element in the vector p. And we have to remember not to use an implied multiply. And then we're going to have x cubed. And before we go on, we should recognize that this, if we left it the way it is, would give us an error. Because p is a vector. And we're going to actually define a second vector with all our different x values that we want to plot. And so we can't cube that, right? You can't cube the vector, you have to tell MATLAB if you want to do vector multiplication or element multiplication. In this case, we want to just do element multiplication. So we'll put a dot multiply there, and we want to do element cubing. So this says basically take each element in the vector x and separately cube each element by itself. Okay, so we've got the first term, so that's the ax cubed term. And we're going to head and copy that so we don't have to retype it, put in our next term, and then we adjust that to p2 and x squared. And then we'll paste again and adjust it to p3 and just x. And then the last term is going to be just p4. Okay, so I hope you can see that we've got the first term is this, the second term is this, and the third term is over here, and the fourth term is here. So I should have x cubed, x squared, x, and then just a constant, and p1, p2, p3, and p4. And I think I've got all my element by element things in there. Okay, great. So we've got our function. And if we want, we can make this some particular set of values for the coefficients. So let's go ahead and come up with particular values for that. Let's just say we've got, I'll just put some random numbers in here. Okay, so we're going to have a is equal to 1, b is equal to 2, c is equal to 3, and d is equal to 4. And we have to come up with values for x so we can plot this. So we'll just generate a list of numbers that are evenly spaced, maybe going from -10 to 10. And to make a nice smooth plot, let's put in maybe 40 values. That should be a nice smooth plot. Okay. So let's generate the y values for our plot. So we don't actually have to type our cube function because we've already defined it. So we just say y is equal to cuber, and we're going to plug in our various values of x that we defined with linspace and p that we put in as our coefficients. And we're going to plot this, and we should use show graph so that if we fiddle with this every time we mess with it and run the script, at the very end it will put the graph at the very front window. Okay, let's do it. and we see we have our plot of our cube function, and we can, if we want, change these coefficients and see if we had a different cube function what it would look like. So for instance, if we had this linear term, if we changed it from 3 to maybe -40, how would that change the way the function looks? Let's run the script again, and we can see now we've got a different function, and we can change any of the terms, rerun it, and see how that plays out. Great. So that's how you run a function in MATLAB.